Recently, low-carb diets, intermittent fasting, and even prolonged fasting have become very popular, and they all have something in common. They move you towards entering the state of ketosis. Ketosis is a state where your body is running primarily on fat from your diet or your body. Ketogenesis is when fats are broken down into something called ketones. These ketones, or ketone bodies, are usually thought of as an alternate fuel source, because instead of glucose, ketones are used to power most tissues as well as the brain. Sustaining ketosis means restricting protein to less than 20% of your calories and carbs to less than 5%. Unfortunately, there seems to be a lot of confusion around ketones. Most people have been taught that ketosis is a dangerous, unnatural state that appears only during starvation or in diabetics. So, with this video, I'd like to clear up some misunderstandings, and I'll present to you why entering this fat-burning state of ketosis can be perfectly natural, and might even be the preferred state for humans, compared to having our bodies always running off of carbohydrate. To see how there can be so much confusion around a topic like ketosis, let's first take a look at the story of the thymus gland. Back around the 18th and 19th century, it was hard to get cadavers for anatomical study. People didn't really like having their recently deceased loved ones cut up for examination. So people called resurrectionists were employed by anatomists to exhume the bodies of the recently dead. Sometimes resurrectionists would even wait near a funeral and snatch the body right then and there. Because of this, wealthy people would purchase very well-crafted, lockable coffins, and they would hire armed guards to protect the graves of their loved ones. The 1832 Anatomy Act even said that if a person died in a poorhouse, or their relatives could not pay for medical expenses, their body was to be immediately turned over to the anatomist for study. This meant that anatomists were much more likely to get their hands on the body of a poor person who couldn't afford such measures. So, what about the thymus? Well, people facing the hardships that come from being poor are of course going to be under a lot of stress, chronic stress. Nowadays, we're very familiar with the fact that chronic stress leads to all types of diseases and that it can atrophy certain organs. In the case of the thymus, stress can reduce its size by as much as 75%. So, what ended up being recorded into the anatomy books as a normal thymus gland was actually a thymus that was severely reduced in size. Then, in the 1900s, a German anatomist called Palthoff was trying to find the cause of sudden infant death syndrome. Many middle and upper-class babies were abruptly dying of this. So, Palthoff examines the bodies of these higher-class babies and notices that their thymus glands appear to be abnormally large. So he concluded that if you wanted to be a good parent, you should irradiate the thymus gland of your child to make it smaller and prevent sudden infant death syndrome. By the 1920s, all the leading pediatric textbooks were offering this advice. Palthoff, of course, didn't realize that he was simply someone who had the rare chance to look at the bodies of children whose thymus was not affected by the chronic stress of poverty. Unfortunately, this misunderstanding persisted well into the 1950s, having several thousands of people die from irradiation-induced cancer. So what does any of this have to do with ketosis? Well, ketones also have the misfortune of being misunderstood due to how they were discovered. Physicians first noticed ketones in the latter part of the 19th century when they were noticed to be in abundance in the urine of patients in a diabetic coma. It was understood that a vast overproduction of ketones was responsible for the terrible symptoms of something called diabetic ketoacidosis. So, for half a century, ketones were thought to be the very negative product of impaired carbohydrate utilization. Only after technology and analytical techniques improved did we understand that ketone bodies are perfectly normal components of the blood. Even if you're not technically in ketosis, ketone bodies are always present in the blood of a healthy person, and their levels increase the longer you go without food. After an overnight fast, ketone bodies supply 2 to 6% of the body's energy requirements, while they supply 30 to 40% of the energy needs after a 3-day fast. Before we continue, being in ketosis through fasting or diet is nothing like diabetic ketoacidosis. Ketoacidosis involves exorbitant levels of ketone production, far higher than what you could achieve even when fasting for weeks. Being worried about ketoacidosis through diet or fasting is like worrying that eating at a sushi restaurant is going to put you into a brief coma, just like that one kid who chugged a bottle of soy sauce on a dare. So, not only are ketones normally found in healthy people, but it's been found that certain tissues actually prefer to use ketone bodies. In fact, as explained in the biochemistry textbook published by W.H. Freeman, fatty acids are the heart's main source of fuel, although ketone bodies, as well as lactate, can serve as fuel for heart muscle. In fact, heart muscle consumes acetoacetate, a ketone body, in preference to glucose. Some people actually purposely enter ketosis through fasting in order to improve mental performance. A study at the University of Cambridge concluded that a ketogenic diet improved physical and cognitive function in rats, and its energy-sparing properties suggest that it may help to treat a range of human conditions with metabolic abnormalities. I guess Plato figured this out for himself when he said, "I fast for greater physical and mental efficiency." Going without food for better cognitive function may sound ridiculous, considering it was for a long while thought that the brain could only run on glucose, carbohydrates. George Cahill and his group at Harvard Medical School demonstrated in 1967 that the brain can use ketone bodies as a source of energy. What he found was that during starvation, ketones are the predominant fuel of the peripheral tissues and the brain, with the brain deriving more than 2/3 of its energy from ketone bodies. Despite this, the body still requires some glucose, even when you aren't eating anything. For example, red blood cells can't run off of ketone bodies because they don't have any mitochondria to metabolize them with. But all of the body's glucose needs are met by the fact that the body can make its own glucose. For example, it can make glucose from the glycerol backbone of fat. For this reason, even during prolonged fasting, people will still keep a stable blood glucose level. This also illustrates that there is actually no dietary requirement for carbohydrate. Of course, vegetables and some fruit are very important because they have all kinds of micronutrients and fiber, but your body doesn't actually require the carbohydrate inside those foods. I'm not necessarily saying that a zero carbohydrate diet is best, just that it's very possible to live without dietary carbohydrate, assuming you get enough fat and protein. There are essential amino acids and there are essential fatty acids, types of protein and fat that you must get from the diet. However, there is no such thing as an essential dietary carbohydrate. Your body is perfectly capable of making as much glucose as it needs. In fact, in the absence of dietary carbohydrate, the brain runs so efficiently off of ketone bodies that you can drastically deplete glucose levels of people in deep ketosis, and it won't affect them. A 1972 paper describes an ethically questionable study where overweight patients fasted for 2 months, putting them in deep ketosis, meaning they were producing a very large amount of ketone bodies. Insulin was then infused into these patients until their blood glucose went as low as 9 milligrams per deciliter, a level that should cause coma or death. However, the patients didn't really react to this. There was no particular change in cognition, nor did their body react to the drastic drop in blood sugar.
The only people in the room who had palpitations and sweating and anxiety were the physicians. The people who had the blood sugar levels that should be associated with coma or death were completely unfazed, had completely normal mentation. It is clear that the human brain is perfectly happy with beta-hydroxybutyrate as not just its majority fuel, but essentially its sole fuel.
Actually, anyone watching this video would have, at least one point in their lives, been in a similar situation, where blood glucose is very low and ketone utilization is very high in their bodies. It's estimated that a newborn's brain consumes on average between 60 and 71% of its body's energy budget. Compare that to the lowly 25% of the body's energy budget an adult brain uses. Despite this massive need for energy, a newborn's blood glucose level is incredibly low, at around 35 milligrams per deciliter. This is half of the lower end of a normal adult's blood glucose level. This means that the newborn's brain would have to be deriving more than half of its energy from ketone bodies. In his book on the health potential of ketones, Dr. Muneta Tetsuo, director of the Muneta Maternity Clinic in Japan, explains that pregnant women, whether they are restricting carbohydrate or not, are producing higher than normal levels of ketones. By comparing the mother's blood with the newborn's umbilical cord blood, he found that out of 416 cases, 70% of the babies were born with even higher levels of ketones than that of the mother. By analyzing the villi that provide contact with the mother's blood to the fetal membrane, Muneta deduced that the fetus must be living in an environment of elevated ketones from the start of pregnancy. And even a month after birth, babies on average had a blood ketone level 5 times higher than that of a normal person. As Muneta wrote in his book, newborns are living off of ketones. Not only is ketosis helpful for supplying the energy needs of a newborn baby, it may also be an important factor in the development of the brain. It's been understood that exercise is beneficial for the brain because it increases the level of brain-derived neurotrophic factor, BDNF, which is a protein that promotes the growth of new brain cells. Because of this, Dr. John Rady of Harvard Medical School has given BDNF the nickname of Miracle Grow for the brain. However, the mechanism for how exercise triggers BDNF was not clear for some time, until a paper came out last year that was headed by Assistant Professor of Biochemistry Dr. Sama Slaman. I think the title is quite straightforward. Exercise promotes the expression of brain-derived neurotrophic factor through the action of the ketone body, beta-hydroxybutyrate. Growth of the brain is very important in a more broad sense as well. Growing a big brain is of course what allowed us to become human. And when it comes to human evolution, efficiency is the name of the game. That is, our bodies had to develop methods for more efficient extraction and utilization of energy, mainly to support our big energy-hungry brain. One trade-off for a bigger brain was a smaller gut. Less energy spent on the gut meant more for the brain. As is stated in a public Library of Science article titled Man the Fat Hunter, to adjust for the high metabolic cost of a large brain, shrinkage in gut size was a necessary accompaniment. A shorter human gut had evolved to be more dependent on nutrient and energy-dense foods than other primates. A smaller gut is less efficient at extracting sufficient energy and nutrition from fibrous foods, and considerably more dependent on higher density, higher bioavailable foods that require less energy for their digestion per unit of energy/nutrition released. This implicates fat as an important food source because it is obviously very energy dense, providing 9 calories per gram. But the efficiency of using fat for fuel is deeper than just calories. Also, our brain's power and capacity for intellect comes not just from the increase in size, but also from the enhanced blood flow and efficient use of oxygen. Roger Seymour of the University of Adelaide and his team found that blood flow to the brain increased at an unexpectedly rapid pace over a period of 3 million years. Seymour says, while the brain was increasing 3.5 times, blood flow rate surprisingly increased 600%, from about 1.2 milliliters per second to 7 milliliters per second. This indicates that our brains are 6 times as hungry for oxygen as those of our ancestors, presumably because our cognitive ability is greater and therefore more energy intensive. This would suggest that the most important fuel for the brain is going to be one that uses oxygen more efficiently. And this is exactly what ketones do. Dr. Richard L. Veach found in 1994 that administering ketone bodies to a rat heart led to a 25% increase in hydraulic work, but a decrease in oxygen consumption. Theodore Van Italia explained this phenomenon in a 2003 article by saying that the ketone body beta-hydroxybutyrate increases the efficiency of energy production in the cell's mitochondria. If you were schooled in the States and attended even a day of biology class, you would know that mitochondria are the powerhouses of the cell. But is this improvement in efficiency happening in the powerhouses of the brain cells? Well, Van Italia says that studies of blood flow and oxygen consumption in the brains of food-deprived obese human subjects revealed values that were well below the normal levels for adult human brains. They suggest an increase in the metabolic efficiency in human brains using keto acids as their principal energy source in place of glucose. People who have done extended fasts will sometimes report a euphoric or drastically enhanced state of mental clarity around day 6 or 7. This is when ketone bodies have reached a particularly high concentration, somewhere over 5 millimolars per liter, depending on the person. In essence, ketone bodies may be a preferred fuel source for the brain, as they provide more cellular energy per unit of oxygen compared to glucose. Getting more bang for your oxygen through ketosis would be incredibly significant for the development and maintenance of big brains. Some of Dr. Dominic D'Agostino's work revolves around taking advantage of ketosis's efficient usage of oxygen in the cells. His research touches on ketosis's potential for treating a variety of illnesses including epilepsy, ALS, Alzheimer's, Parkinson's, and even some cancers. His initial research, funded by the Office of Navy Research, was aimed at improving Navy SEALs divers' diving capabilities. The most straightforward display of ketones' efficient use of oxygen is that simply by being in the state of ketosis, Dr. D'Agostino was able to double his breath hold time from 2 minutes to 4 minutes without any prior training. To sum all this up, when fasting long enough or when protein and carbohydrate intake are restricted enough, our bodies switch over to breaking down fat and making ketones, potentially the most efficient fuel that can be used by humans. The brain is a massive blood flow, oxygen, and energy hog that needs to be constantly fueled. Anything that could enhance energy efficiency would be very important for the survival of big-brained humans. Despite the evidence that our bodies and brains may actually prefer to run on ketones, ketosis is still frequently misunderstood as a potentially dangerous state. Going back to the thymus story, surely children's thymuses wouldn't have been irradiated if the anatomical data of healthy children had been available at the time. And maybe with ketones, the perception of them would be totally different if the first pieces of data didn't come from a diabetic, but say a healthy pregnant mother or a healthy newborn.